All right, welcome everyone to this meetup event number 9 of the Open NLP meetup group. We have 2 speakers today. One of them is already standing next to me. But first I'll introduce you to this setup of today. So the talk will be about 25 to 30 minutes. We have also many people joining online in the Zoom call. And after each talk, we will have a few minutes for questions. So we can ask a question, we can hand the microphone around. For the people online, we can read out the questions in this chat. And then after the 2 talks, we can, of course, mix and mingle here and discuss, but also online we have Zoom breakout rooms for everyone to discuss online about the topics. And now let me introduce already the first speaker of tonight. So next to me is Karel. He came from Belgium just for this event with his tour bus, touring all of Europe now with talk about how to make audio podcasts searchable. And yeah, we'll learn from him how to do that. And very much looking forward to your talk, Karel. Stage is yours.
Thank you very much. So that's not true, actually. We also have an office in Berlin, which I'm also visiting. So, all right. As Julian already said, I'm Karel. I'm a machine learning engineer for a company called ML6, which is a consultancy in machine learning based in Belgium, Germany, and Amsterdam. So we have an office actually here in this building. Yeah. All right, then. Making podcasts searchable. That's the thing I'm going to talk about today. But maybe it's good to first give some overview. Okay, my clicker doesn't work anymore. That's annoying. It always breaks when you need it the most. Doesn't matter. I'll just click it like this. All right. No, actually also doesn't work. I know why. Okay, it does work. Sorry. All right, so first, an overview of what we're going to talk about. I'm going to give you some Christmas context about the project. I'm also going to explain why podcasts are a black box of content. I'm going to show you how you can peer into them. Then I'm going to show you how you can peer into them again, but better this time. And then we're going to do some in real life praises, some bug reports, and some user feedback for the people from Haystack. All right, so first, to frame a little bit this project, at ML6 every year during the Christmas period, we have 1 week where we do Christmas projects. So these are projects that aren't for clients, but are just for fun or just for ourselves. And there are many projects going on at the same time. So we have many different teams, many different projects. So some are just for fun, like could a combination of ChatGPT and DALL-E 2, could it replace like an average Fiverr artist? That's then something we try to figure out. Or can we face swap models into or people into paintings? So that's one thing we tried. We made like a DALL-E chatbot on Fiverr to see if that would work. We wouldn't actually sell anything, of course, but and we also tried face swapping people into paintings, which also kind of works. Then it's not just fun. We also do some stuff for good causes. For example, detecting the spread of coral bleaching in Australia. There's a nonprofit that works on that, which we helped. And also automated quality control for sheltered workshops. That's also a project we did. So, and there are also other types of projects which are basically proof of concepts. So it's like a week where we can experiment with things. For example, optimizing the usage of smart batteries, creating a custom logo generator, and also things like making podcasts searchable. So that's a little bit like the context in which this project happened. So it was 1 week, small team, where we just tried to hack something together. I say 1 week, but then eventually it turned out slightly longer than 1 week. So where did the inspiration come from? Actually, in Ghent, there is a startup, and it's called Checkbot. And it's a platform that collects and aggregates and recommends podcasts. So they saw like a gap in the market that actually no platform was really only focusing on podcasts. And actually Nicola, who was originally going to give this talk, by the way, he knows the founder of that company, and they discussed that actually podcasts are very annoying to work with, very hard to work with, because they already have like search functionality. So what are we trying to do? Making them searchable. They already have search, but they actually don't have that much to search through, because they search through the text that is provided with podcasts. So the descriptions of the episodes, the descriptions of the shows themselves, which is very limited. For example, you have the Lex Friedman podcast, which is one with a big production value, actually, like one of the bigger ones. This is one episode, description, 28 words for 260 minutes, 9.2 minutes per word. Very, very little information to work with if you want to do stuff like recommending recommender algorithms. All right, so that's actually where our idea came from. So what actually makes it so hard to work with podcasts? There are a few problems with them. For listeners, it's very hard to like grasp how a podcast is going to be without listening to a full episode. Like, you can like skim through a little bit, but you can't really see it immediately. And there's also like a lot less money involved than in videos. So there's less incentive to create previews, trailers to draw you in. Some do, but I mean, it's not a lot. There's very limited metadata available. So there are a few descriptions, few tags, few things like that. And then, of course, another actually quite big problem is that anyone can make a podcast. This could be a podcast. So there's a lot of mixed quality content out there. You really need to know what you're getting into. So usually people will resort to just recommendations from friends and stuff like that. So that's something I feel, that's why I chose this project to work on. But we also did a survey on the internet of 100 people, and 100 random other people actually very much agree with this. So you see, finding new shows that you like, 47% finds it annoying. Finding shows when you know what type of show you want to watch, also pretty annoying. And also trying to determine what are good shows. It's like very solid in the eye roll region of annoying. So very worthwhile to solve with AI, I think. So one obvious solution is, of course, if there's too little text, why don't we just get more text, which is called transcription. 1 second. I think it died. Again? Oh no, okay, it's back. Okay. Not press the off button. It's a good lesson. Okay, so why don't we just get more words to search through, to transcribe them with some AI? So it's 2023, so surely we can do that, which is true. Now we can do that. But actually in 2022, there were some issues with that. And one of the main issue is that sound is actually a very annoying type of data to work with because it's super high resolution. A 5-second audio clip of speech, like pretty low on a low sample rate, it's like 100,000 samples. So that's a lot of numbers to work with to detect something from. And then also like speech isn't really text always. I had some colleagues, apparently like verhören is a word in German. It's like where you mishear something. This one's apparently a famous one where German people hear I got the power, but I can see why it sounds exactly the same. So just using the audio to make text doesn't always give the greatest results. So those are very big challenges. Up until September 2022, where OpenAI came out with robust speech recognition via large-scale weak supervision, or better known as Whisper. Maybe like a show of hands, who has already heard of that model? Just to, okay, literally everyone, just to like see, gauge the audience. So it's large. It's large scale because the thing they did is that they literally scraped the entire internet for audio with transcriptions. And the weak supervising part is actually that it learns learns by itself from the data to fill in like the gaps it makes itself in the data. So you don't need to give it a lot of high quality data. You just give it a lot of data and it just learns by itself, which is a quite different approach from previously, where the biggest focus was on like curating or trying to get labeled data. So now we just use the internet and filter out the bad parts. So that changed, and that made this project possible. All right, then on to the implementation. So remember, this is like a project in 1 week. Luckily, we already could start with some data because of the chatbot company that I mentioned before, because they could already provide us with data. So what does data look like in the world of podcasts? It's actually all still RSS feeds. It's kind of an ancient internet idea. It's basically news feeds for websites. So a lot of websites actually still have like this news feed that you can subscribe to. It's written in XML, which is not a very nice markup language. Looks like this. So this is for a Berlin podcast. I don't know if it's actually famous, called Radio Spätkauf. I have no idea. I Googled it and it was like one of the top podcasts, but it's in English. So maybe that's why. Anyway, I tried. So we started out with 4,000 of those RSS feeds, which just basically means we can subscribe to them. And whenever there's a new podcast, we get the URL to that podcast. All right. And then this was our architecture. So we're going to focus on summarizing them. So providing summaries for episodes, because that's a big problem. We took the RSS feed. We ran Whisper in a notebook because we're machine learning engineers. So we don't do good data architectures. Then we have the full transcriptions. And then we use some summarization model like a BART summarizer to get a summary of that episode. So that was the whole plan. That was the idea. We had it all figured out, we thought, until 2 people also got sick during that week. So it was actually me who figured it out, or thought I had figured it out. And then also along the way, apparently, when you Google a lot for like searching, semantic search, stuff like that, you eventually end up at Haystack, which we very much liked for a few reasons. First of all, they use ExcalaDraw to make their diagrams, which we're a big fan of. Their architecture looked a lot more professional than ours, so we thought, okay, might go with that. They offered semantic search. So basically, you plug in your documents, and for free, you get a semantic search engine. You can just search in a meaningful way. And it even provided question answering. So then we were really dreaming of like, and then people can ask questions like, what would be a cool podcast about technology? And then it could just recommend something. So those were the things we were very enthusiastic about. It also offered a lot more, straight from their website. But still, we're machine learning engineers, so we did it in a Jupyter notebook. And then after 1 week of trying stuff out, running some pipelines locally, we encountered one fatal flaw, one mistake in reasoning, and maybe someone can spot what could have gone wrong. When you take a literal summary of a transcription of a conversation, it will still be a transcription of a conversation, but it will just be shorter. For example, this one from this was a summary that we got from an episode of Lex Friedman. So when the model summarized it, it doesn't know that it needs to take a meta level and talk about the conversation. It'll just summarize the conversation. So it'll summarize it into stuff. So I have spoken with Noam Chomsky. That's like kind of one of the right question mark. So that's not what we want. We wanted like a description of the text. We didn't want summary of the text. So we didn't really think that part through. And that's actually where the week ended back then. But it didn't sit right. Like afterwards, I was still thinking, we could have done it better. And then we thought, actually, the problem is that we can't give context. We can't give instructions to the model. but there's a thing that can, and it's right there. So we could have used ChatGPT for it, but it would have been annoying interfacing with their API. So we didn't really pursue it. But I think like the people from DeepSat kind of heard us and from afar, and then they came up with this, which was exactly what we needed. So it's just a part in a pipeline, which you can tell to summarize, or which you can basically give an instruction to, like with ChatGPT or other large language models. So when we saw that existed, we thought, maybe it's worthwhile to pick it up again. And then, like, as a cherry on the cake, there was also a Whisper transcriber node suddenly, so we didn't have to do that part ourselves. So actually, if we had done the project 3 months later, there would have been no project at all because all of it was already implemented. Okay, so with new and reinvigorated hope, we restarted. And this time we were gonna try and do it properly. So we were gonna set up like a whole microservice backend, which handled authentication, it's all in Google Cloud. And then it handles authentication on Cloud Run, it's deployed on Cloud endpoints, and then the Haystack application would also run in Cloud Run, and we would have our own Kubernetes engine, Elasticsearch cluster as a backend. So that was our plan. And so now come like this is where we really try to start working with Haystack in depth. Before it was like running the Colab notebooks. So some user experience, I guess. So there was one very good part, namely that there is already a REST API provided in Haystack. So there is a Docker image that you can just deploy, and it basically does everything that we wanted it to do. And it even came with like a YAML coding, YAML specification language. So you didn't even need to touch the code. You could just specify in a text file, I want this component, I want this component, and this is how they need to chain together. And it just worked. That was the idea. But then we tried to do that. I say bad, but it's more like mildly inconvenient. We have our own Elasticsearch backend, so not like in the examples that they provided. So we wanted to give like custom parameters, like passwords, and things like that. And that didn't immediately work with the examples. Also, like some slightly unexpected behaviors, like for example, we would take some audio and some metadata, we would put it through the Whisper transcriber, but our metadata was gone. That was sad. So took us a while to figure that one out. No, it's fine. So it was obvious that we actually needed to go deeper. And then finally, there was also our bad. Haystack only comes with, Haystack actually is modern. It deploys on a fast API Docker image, which uses OpenAPI 3.0. Google Cloud endpoints refuses to update their API spec. It's very boring, it's very annoying, but it's a huge deal breaker because it eventually meant that we couldn't use the pre-made thing. Then come the ugly workarounds that we eventually ended up making that were very educational, actually. So what we ended up doing was taking the whole Haystack application, not all of it, but a chunk of it, and re-implementing it with our own ML6 maintained microservice framework, which is called Connection, which uses Flask. And that actually allowed for a lot of customization. So once we got under the hood of the code, we actually saw that it was very elegantly written in a way that really lent itself to being adapted, which was abstracted away a bit by the whole YAML pipeline thing. The whole pipeline concept made it seem like magic, like everything would just work by itself. But then diving into the code showed that actually it's not magic, it's code, and it's written in a way that really abstracts away all the complexity so that you can also adapt it for yourself, for your own use case. So that's what we learned by diving into it. For example, we made our own little component, which I was very proud of. I remember the fact that like the metadata of the transcription got removed. I made my own part of the code that reinserted it. So it's like the our big issue was actually that we were really trying to cling on to the pre-made thing without getting our hands dirty ourselves. So that's the lesson to take into account. Then for the final, wait, let me just, sorry. Then, of course, for the final pipeline design that we came up with, it's maybe also interesting to see that we start out with a transcription, which for podcasts are usually quite long, hours, 2 hours, so like those kinds of durations. We split them in multiple parts. Each part separately, we transcribe with Whisper, which is the open API model I mentioned before. And then we take that transcription and we segment it into smaller parts. We take those smaller parts, so all those segments, and each small part by itself, we put into a prompt node, which is connected to ADA. It's also an open API large language model, but a very basic one, like a very dumb model, very lightweight model. And we let that basic model transcribe each separate segment with the following question, like the following segment comes from a podcast transcript, summarize it in your own words. So what are the main topics? What is the sentiment? Who is speaking to whom? And the dumb model won't create a very elegant response, but it will create like a meaningful response. It can extract that information. So then we take all those summarizations from the weaker model, we merge them together, and we put them into a strong model, which is DaVinci. And that one we ask to do the following. So we give it the prompt. The following is a summary of a podcast. Write an eloquent, insightful, yet short synopsis of this text in the style of a New York Times review. Yeah, keep it short, like 5 sentences. Because for some reason, large language models really like to be very long-winded. All right, and then, of course, it is about transcribing podcasts, I guess, and summarizing them. So can't really leave without showing a transcription of or a summarization of a podcast. I'll read out a part of it. So this podcast brings together John Thornhill, innovation editor at the Financial Times, Tom Wehmeyer, author of the State of European Tech Report, and Nicolas Enström, the founder of Skype and CEO of Atomico, to discuss the potential of European tech. It's already like, if you read the rest of it, it's like, it has some good points. Like the sentiment throughout is positive and optimistic, believing that Europe has the potential to create many successful global companies. So that's something I would put under a podcast. All right, then, so to conclude, we did build a custom summarizer for podcasts. So our project basically succeeded. Hasn't been fully deployed publicly yet. We're not going to make it into a product or anything. It was more like a proof of concept idea. There are of course still many improvements possible, like speaker diarization. So it's because podcasts are often conversations. Currently, we just transcribe it as one long part of audio without including the information of who is speaking at what time. So just one big transcription. Speaker diarization is actually when you segment into speakers. So you label this part is said by person A, this part is said by person B. I think that could add like a lot of depth to the summaries. The very long podcasts, like the ones that go over 2 hours, are still very hard to work with. It's like a problem in general. Long documents, it's not easy to summarize those or to really get all the vital information out of it, and probably a lot more. And then, to conclude, like Haystack, it's a pretty cool framework, and it's very versatile. Like you could imagine what other things you could do with it, like a meeting summarizer or a talk summarizer. All right. Any questions?
Yeah, thank you so much for your talk. Very engaging. I really like the story. I now have the feeling I was part of that project somehow with all the insights. And we have some questions already online that I can read out, but maybe we have also some questions in the audience, and I can hand you this microphone if I get it. Yeah. So you get this, and I read out the first question before. And this is about the choice of a document store. So you mentioned you use Elasticsearch, but there are many other document stores you could have chosen, right? In the chat, there was mentioned a Face. So the question is, yeah, why Elasticsearch and nothing else?
Actually, in the very first stage, we did use the Face indices as a data store because it works better in the notebook setting. But in a later stage, we actually just already had someone with experience in setting up Elasticsearch clusters. So we had a script for it. That was mostly the reasoning behind it. Wasn't a very good design choice, I think, in hindsight, because it caused a lot of like the customization problems. But you're right. We didn't think that through entirely.
Okay. Hi. Thank you for the talk. And one question about the hallucination. Do you see some risk there, or maybe this risk depend of the domain when a solution using generative AI is being implemented, or did you experience it?
When actually it started hallucinating mostly when that was like for me a sign that the data that was coming in wasn't transcribed well, or were very short documents. So when you let it generate a summary that is actually longer than what the input is, it'll start dreaming. But in general, when you have a good transcription and you take a good summary length, it never came up with random stuff. So actually worked very well. That was only for like the OpenAI models, of course, which are quite good.
Hey, nice to meet you.
Hi.
Great talk. You said in the end that you don't see it becoming a product. Why not? I mean, you laid out the problem. I can see thousands and thousands of companies and people who would love to use it. Why not sell it?
It's a good point. Convinced. No, actually, because there's a I think for especially as a company, I work for a consultancy company, which is a very different business model from a product company, as you probably know. There's a big difference between developing this, making it into like a functioning thing, and bringing it into production on a very large scale, which would require a lot of maintenance. Like there's a lot more work to building a product than just building the product, I think, if you want to ship it to customers. So that would be that's my reasoning, at least. Maybe I'm wrong, but
sell it.
Of course, go for it. Like if you recreate it, it's yours. Like it's an open source framework.
Nice. Another question from the community online was about splitting the podcasts into chunks and then summarizing them separately, and what challenges that creates, right? Whether the model is missing context and things like that.
Actually, I think when I go back a little bit, I did the whole thing, right? So this is actually the part. So we first do segment all the audio. So we first split the audio because Whisper only has a limited input size. Then we transcribe it, and then we segment it again into very short documents, which are 500 words long, something like that. And then we take those segments and individually we ask model to give the most important parts of those segments, of every individual segment. So we actually do the thing you propose, I think, unless I'm misunderstanding it. And then we take all those segments and make it into one big transcription.
One last question.
But question related to that, you segmented it at first based on what, just randomly, or you have some timestamps, or?
That is indeed at the moment random. So it's just like at 5 minutes, I was thinking of building some overlapping parts to make sure that you don't lose any information, but that's also definitely a thing we could improve. Thought about it, didn't implement it yet. Getting there.
Thanks.
All right. Thanks again to our speaker. And now let me introduce to you the second speaker of today. So it's Sebastian Ruder. Sebastian is working for Google Research, and we know him for quite some time, I feel. So maybe some of you remember a paper by him, a quite famous one about Ulm Fit. So about transfer learning from a few years ago. And I think it's the foundations probably of transfer learning in natural language processing. And today he is here to talk about underrepresented languages and what NLP can do with and for these languages. Sebastian, thank you for being with us tonight.
Thank you. Hey everyone, it's great to be here today and great to be able to talk to you in person after all this time, like online and in Zoom meetings. Also, yeah, right. Cool. And today I want to talk to you about large language models, which I'm sure you've heard a lot about recently, maybe, and or in the previous talk as well. And I want to talk to you in particular about what one challenge, which I think is one of the biggest challenges for these models still to date, and where I think there's still a lot of headroom and a lot of potential left to actually solve that, which I hope to demonstrate throughout this talk. During the talk, I'm mainly going to talk initially just about the prior work in this area and the status quo. Then I'm going to highlight some recent and promising progress in this area. And in the second half, I'm going to talk about what I think are some outstanding challenges, as well as some potential ways that we can address those challenges in practice. So the main issue at the heart of this talk is kind of the issue of language diversity around the world. In particular, you may or may not know that there are around 7,000 languages spoken around the world. And if we think about this huge number of languages, we also need to be aware that these languages are spoken by a large number of speakers. So it's by far not the case that only like a few hundred languages are spoken by millions of speakers, but more than 1,200 languages are spoken by 100,000 speakers together. And the top 400 languages spoken around the world each have more than 1 million speakers. So if during the talk here and in general we talk about kind of doing multilingual NLP and NLP for kind of beyond English and for more of the world's languages, there's really a huge part of the population of the world that are currently not adequately served by kind of existing technology. And one particular kind of linguistic region and language family that I want to specifically focus on is the languages in Africa, specifically because Africa is one of the most linguistically diverse continents with around 2,000 languages being spoken there. About 100 of those languages are typically widely used for communication. And more than 10 of these languages have each more than 10 million speakers. And most of the current models these days, that I'm going to show you to you in a bit, actually do not support most of these languages in practice. To make these numbers a bit more concrete, you can see here some figures in terms of the how well these languages are represented within kind of machine learning and NLP research. And here on this graph, we basically can plot for different languages the number of speakers per million for those languages, and then the number of papers that reference those languages kind of divided by the speaker numbers. And if we kind of sort all the languages of the world based on this figure or this value, we get a few languages like Irish or Basque, which have comparatively quite a small speaker population, but a comparatively outsized research attention, because languages like Irish and Basque have, despite being small, very active research communities that specifically focus on developing models and developing resources for these languages. Then kind of a bit further down in the table, we have kind of more major world languages like German, English, or Chinese here, which are spoken by large number of speakers, and which also have kind of their fair share of research in NLP. And then at the bottom rung of this ladder, we have kind of most of the world's languages, and also most languages in Africa, which are spoken by tens of millions of speakers, but have comparatively very few papers developing models or even evaluating on these languages. So in practice, African languages, kind of in proportional to their speaker populations, are severely underserved in terms of research attention. Late here. All right, and so going from the reference and presence in the papers, we can also look at the people actually doing that research on the ground. And here we can also similarly look at kind of top conferences, both in NLP and ML, and kind of chart here how many people with an African affiliation, so how many people who are researching at an African university actually publishing in those venues. And we can see again here that those are really, so here these are like single digits compared to now, like most of these venues get thousands of applications every year. So it's a very minuscule amount of actually people from those regions actually doing research kind of in NLP or ML in general. So with that kind of out of the way, I want to talk a bit more about the general state of the art with regard to NLP research. And most of you are probably kind of aware these days that they are that current models in NLP like ChatGPT or GPT-4 or Palm mainly consist of two ingredients. The first one is kind of a large, very generalizable and scalable architecture. These days, the architecture is the transformer, so kind of a stack of multiple attention layers, combined with transfer learning. So these models' ability to learn from large amounts of unlabeled documents online that can then be applied through either in-context learning or fine-tuning to a wide variety of different practical applications. Now, with regard to multilingual NLP, the models look very similar to models that have also been applied to English or monolingual settings, in that these models are also kind of stacks of multiple transformer layers, like I just mentioned, with kind of a wide variety of different names, but most of them kind of based on like this BERT like model, which is kind of one of the most standard transformers that have been pre-trained, having now not just a vocabulary that represents tokens in one language, but in many languages. And at least until recently, most of them being only on the order of hundreds of millions parameters, so comparatively smaller than the largest monolingual or English-centric models. And most of these multilingual models are also trained on Wikipedia and on data of the web in around 100 languages. Now looking again at kind of the presence of African languages in these large language models, we can see here that a couple of recent models are trained on like a small number of these African languages in practice, but still a comparatively few number overall. One reason for this kind of scarcity of African languages that are covered by these models is the lack of pre-training data in these languages. So if here we can see a graph of the distribution of different languages here into common pre-training resources, Common Crawl, so data from the web, and Wikipedia. And most African languages, for instance, are kind of situated towards the tail of that distribution or are not really represented like at all. So they would be kind of way further towards the right side of this plot here. The other issue why these models still typically choose not to represent or not to train on these languages is that even for languages where there's data available, there have been observed severe quality issues for these data sets. For instance, a lot of data sets that have been automatically collected either via data mining or via automatic alignment for machine translation. Kind of prior studies have basically observed that almost 50% of the sentences that were for some of these languages said to be in one of these languages were actually in a completely different languages, or just nonsense, or just some HTML code that you wouldn't want to have in this pre-trained corpus. All right, with regards to kind of giving an impression of how well these models are actually doing in practice, one kind of common benchmark that I worked on in the past is basically this kind of a multi-task benchmark. So this consists of multiple tasks, each covering a different number of languages on which you can basically evaluate a pre-trained model. to get an impression of how well this model generalizes to other languages. And a common evaluation setting has been for multilingual NLP, what is known as zero-shot transfer. And the main motivation for that is because typically you do not have training data for each task in each language. So these models have typically been trained on by fine-tuning it on a task in a certain language where you have a lot of data, that is typically English, and then they are applied directly to the same task in another language now. And because most of these models have learned quite or somewhat generalizable multilingual representations, in practice, people have observed relatively strong cross-lingual transfer performance. So in this setting, just to give you an impression of how progress has looked like on this representative benchmark, we can basically see that from 3 years ago up to like last year, there's been kind of a steady improvement on this sort of representative multilingual benchmark. So just by looking at this plot, we would get kind of the impression that we are getting closer overall to human level performance in terms of multilingual NLP. But what a benchmark like this and most other benchmarks in this area really obfuscate is the languages that are actually evaluated on. So this is just kind of a very schematic representation where on the left we have the languages and on the right we have the different tasks. And each cell basically indicates if it is green, the given language is covered by the task. And what we can see here, just at a high level, is that there are only very few tasks here that cover most of the languages, and then most of the other tasks cover maybe only around 10 languages or so. So if we look at, and particularly for African languages, looking at the African languages here, we can see that most of them are only really reflected in two data sets, which mostly focus on sequence labeling, so just labeling each word in a sequence based on its named entity tag, for instance. So just based on this figure, we cannot really make any kind of generalizable statement about how well these models actually do on these more kind of underrepresented languages. And so just taking a step back from these benchmarks, I want to look at kind of recent models in the general area in NLP. And in particular, we can characterize these models based on the fraction of non-English training data or data that they've been trained on. So you can kind of see here, basically, the higher this fraction is, the more multilingual data the model has seen. So if it's 100% non-English, the models have only been trained on kind of non-English or multilingual data in many different languages, whereas models here on the bottom have been exclusively trained on English data. And what we can see here is that up until very recently, there've been kind of two strands of research in NLP. There've been, for once, kind of models developed that are primarily multilingual. And then on the other hand, kind of the more mainstream of NLP research with models like GPT-3 or T5 or recently Palm that are much more English-centric. So that are where the vast proportion of training data is just English, and then there's maybe a small proportion of data in other languages. And the kind of maybe bright side here is that if we look until like recently, there are new models like GPT-4 or also very recently Palm 2 from Google that, at least based on their capabilities, are more multilingual. Of course, with these models, we don't know exactly like the fraction of multilingual data that they've been pre-trained on, but at least based on their evaluation, they are already more multilingual than the models before. So just to give one example here from the like Palm technical report, this is basically looking at language proficiency exams. So if you're learning a foreign language, you can take standard examinations to kind of certify a certain degree of competency, like C2. And if we basically take a model like Palm or Palm 2 to take these same exams in different languages, a human would take in languages like Chinese, Italian, French, and German, still mainly languages with a lot of data. These models actually pass those exams in basically all cases. So at least for like the kind of high resource, like head of that distribution, these models are already like very multilingual to date. But like for the long tail and kind of the more like African languages, there's still, even with these large models, some way to go. And just kind of one other example of like abilities where I think it's very really exciting and promising what these models are going to be able to do, even for kind of developing or programming tasks. For instance, I think we'll soon be able to do like programming kind of natively in different languages as well. So here, models can not only solve a bug in a kind of standard set of code here, but also do that with line-by-line comments in Korean, for instance. And yeah, and personally, I'm particularly excited also looking at languages like German, where we can prompt these models to, yeah, for instance, provide simple explanations, and they really provide outputs that I think that are useful. That here in this case, I would be happy to explain to my mother too as well. All right, so kind of the main takeaways from this part is basically that I think there's quite a large discrepancy of the kind of incredible linguistic diversity in the world, as well as in certain continents like Africa, but the comparative scarcity in terms of or lack of attention in terms of research. State-of-the-art models have definitely made much progress, but progress is still kind of lacking on this longer tail of languages. And finally, models still tend to perform quite poorly on languages that they haven't seen a lot of data from during pre-training. So recent progress in this area, just to highlight a few bright spots, a lot of that is really driven by the community and the like open source community, and it's really like happening open source. And one community I would like to highlight here is known as Mazakane, which in Zulu means we build together. And this is a community that was started at one of the kind of machine learning conferences / summer schools, which is mainly organized on Slack. But despite being quite a very large community, and a community where most of the members come from different African countries, has managed to publish in quite a few different reputable conferences and workshops. And this and kind of other efforts have also led to a lot of kind of local communities focusing on local languages or local efforts. For instance, in Africa, focus on like Hausa or languages spoken in Ghana, as well as documenting and cataloging resources in Africa or in Arabic that can be used to train or evaluate these models. And what is very exciting for kind of people working in that space, because I mentioned before, there's kind of a key lack of like high quality data sets to simply measure and track performance of our models on these long tail languages. And in recent years, like over the last 2-3 years, there really has been a wave in an influx of new data sets developed by speakers of these different languages for like all kinds of different languages, not only in Africa. From data sets from machine translation to speech recognition to kind of standard NLP classification data sets and other ones like for summarization or natural language inference, for instance. And just to highlight here, just two examples of two data sets I collaborated on, just because I think a lot of these data sets not only allow us to make progress for these languages, but also solve kind of deeper and interesting linguistic and machine learning challenges. So for instance, here in Niger Senti, which is a data set for Nigerian languages, and in Nigeria, there are quite a few different languages spoken kind of continuously. So there's a lot of kind of code switching and changing between different languages, even in the same utterance going on. And this is particularly kind of common in social media or Twitter data. Or similarly here, we can see Mazakaner, which is a named entity recognition dataset for 10 African languages. And this also, I think, interestingly shows kind of the differences in terms of, from an English sentence, how different entities are realized in different African languages. So we can see different scripts, for instance, being used in Amharic, or simply time expressions being realized or instantiated differently, even without numerals in some of these languages. And also on the modeling side, a particular effort is kind of from these like very large multilingual and kind of unwieldy huge models going towards more specific and more language specific or language family specific models. And here a really exciting trend is the development of like more African specific language models. which specifically focus on a small subset of African languages that are spoken in different regions. And because a lot of these languages also share our linguistic commonalities because they're part of the language family, the model can also exploit kind of positive transfer and transfer learning when learning representations between these different languages, which in practice means that despite being much smaller in terms of the parameter size, these kind of dedicated models can actually outperform these huge multilingual models on these specific African languages. So lastly, so here the takeaways from this part are basically that I think overall there's really an exciting kind of growing ecosystem, very much community driven and in the open source community for these languages. There are a lot of grassroots initiatives really, and also at the same time kind of increasing interest both on the academic side, but also from like certain industry labs and companies. And so with that, okay, I just want to highlight quickly what I think are some of the outstanding challenges in this area. The kind of biggest one really, and probably what you've already like realized before, is really the stark lack of data. And I think one interesting way to kind of visualize that is to basically plot each language with a point here based on its availability, so how much data is labeled data is available for it, as well as how much unlabeled data it has in Wikipedia. And if we do that for most of the world's languages, we can basically identify 6 different groups here. So we can see languages here in the top that have both large amounts of unlabeled and labeled data available. So for these languages, we've already have models that do very well. And then as we go towards to the bottom and to the left here, we have much more languages which face this huge lack of data. And the interesting point is here that actually for most of the world's languages, we really have basically no text data available online at all, or very hard to obtain. And for a comparatively small number of languages, we have like few textual resources available. The other limitation for these languages in practical settings is also a lack of compute. So if we want to actually deploy these models for these languages in those regions where those languages are spoken, in many of those regions, we also face computational constraints. So for instance, if we just look at one of these factors, the cost of mobile data, this is also much higher for languages that have less data available to them. And the last point I want to highlight here, and that is maybe more of interest to you if you're kind of interested in languages or linguistics in general, which is kind of language typology, or how languages are linguistically or morphologically structured. And in particular, one thing I just want to like highlight here is that the languages so far that we've been focusing on kind of language research, which are mainly languages that are spoken in Europe, are kind of as a whole very much unrepresentative of the remaining set of the world's languages. So kind of one feature here, there are basically some linguistic resources online that for each language have a catalog of 180 different linguistic features, where each language has a different value. And we can take all of those features and put them in like a plot with PCA. And based on which we identify some like high density regions. And most of the languages that are currently used in NLP research are in very much low density regions in this space, which means kind of effectively that there are a lot of morphologically rich languages around the world, so which have very rich morphological structures, which are currently not really represented, together with a lot of other features. And one of these features, just to highlight very briefly, is tone. So whether kind of the way you the pitch or the way you pronounce something is going to change the meaning, which is almost completely absent in European languages, but very, very common in African languages, for instance. And is in some languages basically indicated lexically, but is very much prominent in speech, for instance. And lastly, just in African languages, the interesting part here is that there are kind of a few language families where languages share different commonalities among them. All right, so just finally, I just want to highlight a few things regarding the future of NLP in this area. I think there are for each area a couple of things that we can do, but just for brevity, I'm only going to focus on the first aspect here. which is about kind of developing and creating data that is like more practical and kind of reflects the real the needs of speakers in those regions. And here, one thing to notice for many of these languages, the existing data sets that we have available, or many of them that have been developed, are based on translations. So most of them take some existing data in English and then translate that to a different African language, for instance, which is kind of a very, very effective or very cheap, comparatively cheap way to get some new data. However, kind of linguists know very well that the language in translations, known as translationese, is not really actually natural language, because it's has like underlying biases or is very much biased by the kind of original source data. So just like structurally, it actually doesn't really reflect the way native speakers of a given language would actually speak or utter a statement. However, another kind of crucial point is also that if we translate data, the kind of concepts and underlying information that is represented and reflected in that data is also biased and kind of has the same viewpoint of the original data, which is commonly produced by crowd workers in the US or from English-speaking countries. And that is even common in like data sets like ImageNet, which are very widely used. Because ImageNet was kind of annotated based on the English WordNet by English-speaking annotators, it also has very much Western-centric concepts, like the concept of tailgating, which is very common only in the US. If you celebrate in front of a sports stadium, have a barbecue from the trunk of your car, for instance. Beyond that, I think it's also really important just to create data sets that is informed by real-world usage scenarios that really reflects kind of the underlying needs of the speakers of these languages. Another kind of issue that I just mentioned is that data and textual data for these languages is really very scarce online. So we cannot really get away with training text-only models for if we really want to scale to most of these languages in practice. However, most of that data, or that doesn't mean that these languages actually have no data at all. It just means that it's in formats that we currently are not using or that are locked for use by current models. And these can be books or documents that are handwritten and haven't been digitized. These can be also resources like lexicons or podcasts, for instance, or videos on YouTube. So in order to really, I think, make progress for like the long tail of languages, actually being able to use this rich set of multimodal data, I think is really crucial. And beyond that, it's also really, really a practical concern, because in practice, while many languages that we speak might have kind of a rich and kind of fully developed orthography, but many languages around the world where computational interfaces or like phones or computers have not been that widely used, are often more commonly spoken than written. So actually, in order to properly serve and build technology for these languages, we actually also need to develop models that are speech first, for instance. So down the line, I expect models to get both multilingual as well as multimodal as well. And just to give, like, for the final stage here, just give one example how we can leverage some alternative data sources that so far have not been untapped. And very interesting data source, or if we look at kind of the coverage of different resources that have been used to train models in practice, we can see that kind of the data that has been used to train models like multilingual BERT covers only about 1% of the world's languages. If we look beyond to Wikipedia or Common Crawl, that covers about 4%. Going beyond that, the Bible as a textual data set covers about 1/4 of the world's languages. And then there's another resource, which are bilingual lexicons. So these are simply lists of words in one language on their translations in another language. So very simple and obviously not as rich as like sentence level or really structured or paragraph level data, but still more data than is available for many of these languages in practice. And here, kind of in a like brief study, I just want to mention just one way that we can use such a kind of understudied resource to augment these models. And the main way is basically to use these lexicons to generate data for these models, because in practice, the best way to provide information or inject knowledge into these models these days is via data or via providing some examples or instructions here. And for these kind of, for some multilingual models, basically ways that we can adapt them is either by fine-tuning them on some monolingual data or fine-tuning them on some task data that we may have translated to another language. So we can basically simply use these lexicons to generate pseudo monolingual data. So by simply doing word by word translation on data that is English and translating if a word is contained in that lexicon, simply replacing it with its lexicon translation. And we can do the same thing if we have data for a given task, doing also this word by word translations, combined with some additional strategies to like refine and improve further the quality of that data. And just to quickly highlight the results here in a setting where we have completely no textual data for training these models at all, we can see that actually doing this sort of pseudo replacement for like fine tuning performs kind of best. So this is all like improvements over the baseline. So all of these basically for these like very understudied languages lead to percentage point improvements of like 10 or more in some cases. Whereas in the setting where we have some unlabeled data for training these models, we still see some improvements, but a combination or just doing this replacement based on unlabeled data may actually perform better. And just finally, I want to highlight just for prompt-based methods, like another way in which we can maybe like rethink or better use data that is available. And one method that you may have already heard of is known as chain of thought prompting, which particularly for reasoning-based tasks, like mathematical reasoning, where given kind of a simple word problem where you might need to add or subtract or do simple mathematical operations. In practice, if you train a model or instruct a model to simply predict the answer directly, the model might often fail. However, if you do kind of augment your instruction with this chain of thought, so simply a rationale that provides step-by-step instructions how to arrive at the corresponding answer, models see quite a significant improvement on these types of reasoning tasks. And in a recent study, we've kind of applied a similar setting, like in the multilingually as well, where we have kind of multilingual or mathematical reasoning problems in different languages and experimented with different ways in which we can provide these rationales to also effectively improve performance in practice. So with that, just the takeaways from this section are just that we, I think, should try to create data sets that reflect kind of the needs of local communities, that we should really focus on like multimodal models or resources in the future, and also consider kind of the like full scope or alternative data sources if there's not sufficient text data available. So with that, just want to like call out again that I think just focusing on kind of data and maybe what people actually care about is important. I think really now is the time to actually make progress. Never have models been so accessible in different languages. Never have we had so many different like data sets and resources available in different languages. And overall, I think there's really not something a particular lab or particular company can do by itself, but really requires a whole, like, the whole open source community to basically work together on this effort. Thanks a lot for your attention.
Yeah, thank you, Sebastian. Very inspiring talk. I like the closing words. I also like the focus on applied research and all the paper citations. Definitely some stuff to read. Are there any questions from the audience, maybe? Okay, so one question I can read out from the community. It was a bit about spoken languages or dialects that are mostly spoken and for which are not much or not at all any written documentation. And the question is how we can make these large language models learn also these languages that have no written documentation.
Yeah, I mean, yeah, I think for particularly dialects, if they're mostly spoken, if they don't really have kind of a written orthography directly, I think really like speech or multimodal models are the way to go. And kind of developing, looking at either resources that are already available, like YouTube, or developing data sets that actually represent or reflect, contain data in those dialects. I think there's also a lot of dialects that are written or that have like more written data. For instance, up until recently, models have mostly treated kind of Portuguese as like a single like monolithic language, where in fact there's a lot of differences between Brazilian and kind of European Portuguese. And I think there's also, I think beyond just kind of spoken only dialects, I think there's a lot of other like varieties in dialects that do have still textual data where we can, or where we need to adapt our models before as well.
Yeah, thanks for your talk. I have a question. So with regards to different scriptures of languages, so maybe in a monolingual model, but also maybe in multilingual models, how do you deal with different scriptures?
Yeah, great question. So kind of in general, like the task or the setting of converting between one script in one language to another is called transliteration, and many languages have or use different scripts in practice, or may also switch between the usage and different scripts, and that in India, for instance, is very common. And in practice, I mean, it's not like with all of these models, it's not something that is really kind of baked into or where there has been a lot of like care maybe taken in the pre-training. But what we've observed, for instance, in like some of these like recent large multilingual models, if you ask them like the same question in like different scripts in the same language, the models are still able to kind of like naturally understand the meaning regardless of the script, and also able to kind of fluidly convert between different scripts in the same language. Yeah, for many languages, or at least most common scripts, I think there's already been a lot of progress or just advancements purely by virtue of them being included in this large amount of pre-trained data in these languages.
Thanks for the great talk. I was wondering, with the very large recent language models, I mean, obviously one way to make them more multilingual or for those languages is feeding in more data in the pre-training process. Do you think that's the way to go forward, or do you see a path of like adopting the existing models later then to maybe more specialized languages, or using the data in a more efficient way in an adaptation step?
I think there's definitely different directions. I guess like one disadvantage like with these huge models is that just training them from scratch requires a huge amount of computational resources. So that's effectively, even for big companies, I guess something that is not done every day or only kind of in certain intervals. And in the meantime, so kind of for the next models, I'm sure there can be like more work on actually improving the quality or the kind of composition of the training data, and hopefully having that more diverse, multilingual. But in the meantime, also for existing models, there's different ways in which to adapt these models to different languages. And then there's also often, of course, the kind of the trade-off between like most of these like huge models are not really deployable like directly in practice. You need to apply different techniques to make them smaller. So depending on the set of languages you might have for a different application, you might want to have a model maybe that's specialized towards a certain set of languages, or if you only really care about a certain set of languages where the model doesn't do well on, maybe actually having some of these models that are specifically trained on a certain subset of languages and can really just excel and serve this set of languages very well might be kind of a good compromise. It really kind of depends on the like practical limitations.
Hey, thanks for the talk. Yeah, I am thinking about, is there also research showing that the performance on English increases by including other languages, and by therefore like driving the development of more and more multilingual models?
So in practice, I mean, it's less often so that kind of performance on high resource languages increases by including kind of additional like low resource languages. But like with these like new models, for instance, with the like recent Palm 2, for instance, even though the data is more multilingual compared to like the previous like Palm model, just by kind of virtue of additional training techniques or additional like training methods, also the English performance improves. So you can definitely have like stronger multilingual models that are still as strong or even stronger than like comparable models in English, by virtue of having better, like more data efficient modeling, maybe better objectives, more high quality data. So these don't need to be kind of opposites, basically.
Yeah, I have a question very similar to that one, but in the other direction. You mentioned that the large language models have a Western bias, and at the same time, because of the feed data is mostly Western language data, and at the same time you say that we should develop language technology for the local communities that could be very different contexts, very different topics, very different approaches. Do you think that has an effect on zero-shot ability of the models in the small or in the large languages?
Yeah, for sure. I mean, I think one, in general, these models kind of inherit like the bias or kind of the perspectives of the pre-trained data or kind of the data that's represented during pre-training. And there are different ways. I mean, a lot of the current models basically are used like additional instructions or kind of additional ways in which these models are further fine-tuned for certain like, I guess, alignment or like other objectives. But even, and I think there it's kind of interesting to really think about, okay, what kind of like values or what kind of things you want to instill into these models? Are these kind of properties really reflective of all of the communities? Or is this also something that you need to do in a more kind of language or like region specific manner? And I think we're only kind of scratching the surface of that and really figuring out how to like either remove biases or kind of inject more positive biases into these models.
I think we have one last question from the audience.
Hey, thanks for the great talk. I'm actually curious about the thing that you were mentioning before. I think one data point you mentioned that in low resource languages, there are cases where 50% of the sentences are from a different language, right? So I'm curious about like, what are the techniques that you kind of, I presume it would be very important to remove those, right? So that, you know, the model learns properly. Could you elaborate a little bit more on like, what are the techniques that you would follow to kind of, you know, exclude those?
Sure, yeah. So what I mentioned before, this was just on a like, briefly highlighting that. So a lot of the data sets, I mean, most data sets beyond ones such like Wikipedia, for instance. I mean, Wikipedia, if you go to Wikipedia of a certain language, you know, or in most cases, data is in that language with some kind of, like some exceptions or some weird corner cases. But many of the data sets that are or large scale data sets in practice is very like not really scalable to like identify or data for each language at scale. So a common kind of method here is kind of in addition to just scrolling data from the web, then using language identification. So kind of a separate model that basically given an input text tells you which language is in that text. And this can be helpful basically to identify first which language text refers to. And these data sets that I mentioned, they basically use language identification to, or some existing labels to basically say, okay, this data is in that language. But because language identification is also kind of like limited in terms of the model, and often is not really trained or not really familiar with the very large diversity of data that is possible on the web, where you can have like very different forms of data or people experimenting with different Unicode symbols or different things, which the model might think is an African language, but it's actually just some emoji sequence or some funny sequence of characters. So there's a lot of kind of things like that come up here. And in practice, for kind of very large scale pre-training, you basically want to additionally be able to just identify like high quality data. So not only isn't that language, but does it have like little noise? Is it very natural? And so you can kind of imagine like additional like classifiers or additional methods here on top that allow you to filter out things. And these can either be like machine learning based, which you can train separately, or heuristic based. You can use some like word lists, for instance, where you know already these are terms that are very often used in certain languages, and use these also to maybe pre-filter your data. So just the like ensuring data quality is kind of a whole research area, or like a whole like unexplored research area by itself, I think.
All right, thank you so much again. Looking forward to publications in this research area by you. Another round of applause. And now it's time to probably grab another drink, follow up on the business idea discussion, maybe any other discussions here. And for the people online, we will have some Zoom breakout rooms. Thank you.